Hello, welcome back to Blender Sushi Live Coding. In this episode, I'm gonna talk about stair and ramp. It's kind of like a one of element of architecture. If you think about it, I when doing like a lot of procedural thing, I accidentally kind of touch a lot of architectural kind of elements like a floor, ceiling, wall, and maybe like buildings, even like a terrain. It's all very architectural related. I don't know why, but yeah, but anyway, I will talk about ramp in this one. It's not like necessarily like making like a normal stair or like spiral stair. I will eventually like make one of those, but for now, I'm just gonna focus on a ramp. So ramp, if you think about it, you can build a ramp by using you start from a plane, and let's have a look. I'm kind of improvising. It's like an improv, so I didn't prepare this. So you start with a plane, and then to make a ramp you kind of need to push one of these 2 points need to be lifted up, right? And by doing that you actually create a ramp. There are many ways to do this, but there is one that I think I will try to do. So let's look at it. Maybe the ramp should go either in y or x axis. We know that we can kind of extend the ramp at some point, maybe something like that, and we can extend it or make it shorter. I'll save this. This is ramp. It's gonna be like kind of goes back to the very components, but since we are using the plane, so we need to work within the plane kind of framework. So frame in order to make it up. Okay, I think we can use rewire, vector rewire, and we know that if we plug this vector into this guy, normally we can flatten an object, but in this case we can use this scalar value and the z axis. So yeah, let's try. So by default we really can flatten and place any vector kind of components using vector rewire. But if I know that if I use range float and kind of plug this into the scalar, we start to get something that's a little bit like a RAM. But the problem here is that instead of a ramp, we are getting uh, because each of the vector is kind of going up on every steps. So that's not what we want. We kind of want to have, for example, the first two points need to be on the ground, and then the next one goes up a little bit by a little bit. So that's kind of the plan. Let me try making kind of like a grid 10 by 10. You see, this is a little bit more obvious. 10 by 10 in X and Y, and then let me check this, see if I kind of using the count. So I think the ramp is better off going in the Y directions for whatever reason. So that's kind of creating a ramp, although it's a little bit tilted, because like I said, in order to correct this ramp we need to kind of modify this number. So by default it's like keep going up, but we actually need to double this number, like 0 0 and then 0 0.04 0 0.04. So we need to double it or even triple it depending on how many points we have here. For example, we have 10 points here in the x directions, and we need to flatten that. That means the first 10 points need to be, this thing needs to be repeated 10 times or 5 times or 2 times depending on how many points we have. Okay, so that's the idea. How do we repeat a number? We can, for example, I'll just make this 10. So this is I want to repeat each number 10 times. So let's do that. Repeat, list repeater. I just plug this into that guy and give it a test for comparison. So let's say I want to repeat this 10 times and unwrap it. So this is, see, this is actually doing it already, 0 0 0 0, and then this number, and then it's going up and going up, and so on and so on. 10 by 10, so we need this setup will work for like 100 points. So this number, if we plug into the scalar, it doesn't work because we need to join the value once again. After we use list repeater, we often want to join it, and then suddenly we have a proper ramp because the number is now correct. See, it's like 0 0 0 0, and then continue on. It's become a single list. The reason we use a list join is that if we use list repeater, the list itself actually broken apart, and is depending on the level and all these settings. From these numbers, 10 numbers, going from 0 to number 2, we actually turn it into this number, but we need to repeat it 10 times, so it's depending on, I think these numbers correspond to the X and Y in case of ramp. Okay, this is so yeah, now we have a proper ramp. So if you imagine like if you have a floor and you have a wall, and if you want to make like a ramp or like a stair, for in this case it's just a ramp, you can easily kind of assign that from that floor grid. If you want to make like a ramp, you just assign it, okay, this should be a ramp and it should be stair going in what directions, so we can easily use this. Okay, so let me check this real quick. I'll save this. This is the basic, and then gonna refine this a little bit. So this is ramp. If I'm extending in the X, so the ramp starting to go a little bit weird because the X correspond to this number. So this the repeat. So integer value. Let's see. I make it 10. Plug into this guy and make this one also 10. Now, okay, that's actually probably the wrong one. 10 should be on this guy. So now it's correct. So no matter, okay, we have the something like this, we can extend it, so we start to have proper ramp. So that's working. This one corresponds to the height of the ramp, this one to the lower value of the ramp, and the stepping, this one is more like for the plane itself. How about this guy? This guy is actually corresponding to this number. So this to that guy. So now, no matter how I make this, it will create a proper ramp. So lower height, maximum height, and the detail of the ramp, and we can also do that. The direction of the ramp, maybe if you rotate it, but then I don't need to worry about that for now. That will require another setup. But there's interesting thing that you can do with this scalar number going into the vector rewire. This is actually very interesting. If you use something like function, list math, actually not list math, but like a proper math. I think this one. So there's a multiplier. There is all this sine wave and a cosine. See, suddenly you have this quite robust kind of system. You can of course adjust this function a little bit more, but if I just try all of this one by one, kind of scroll through these. Some of them won't give you any good value, but things like log, or actually round. Actually, round is interesting one. See, round and floor or ceiling actually give you something that looks like a stair. A little bit. See, if I turn off the points and turn on the shading. So that's ceiling. There's a floor, and there's also round and things like a modulo, for example. modulo. Give you that that's kind of repeat. It's a famous like a modulo kind of repeat. It looks like that. So depending on the pattern that you give into the scalar, you will basically can create stair or anything kind of like a pattern, even like a, you can think of it like a musical pattern or something. So that's how it is. It basically, you don't need to use a plane and then going through all this range and then etc. Because in fact you can actually just draw like a line. For example, to make a ramp, you really just need, you start with a line like that, and then you just extrude it, or maybe you make a stair. Stair goes like this, and then you just extrude it, and then I don't know, you add this part. The tricky part is I think this part, and to make it solid. um, but with this method you kind of have a plane right away, and you can use this for anything basically. So yeah, basically all of this, if you can see like some kind of profile, and you can kind of think of it how to build this procedurally, you can build it. Yeah, so hopefully this is interesting, because I did find this interesting because I don't know, it's kind of unusual kind of thinking. Let me try something. See, like if you start to play around with the functions and you start to get interesting result, and you're kind of wondering how is this happening. I don't know, like it's not about math or anything, but it's more like something. So it's a sine wave. If we make it a little bit higher or lower, we can also kind of push it out. I don't know, you can end up with a interesting kind of structure really quickly. I know there's this Denmark architect, I forgot his name, but I might talk about it again in another live noding. He make like this boat house that's made of like a ramp. Imagine if this is like an idea for someone to sit in a cafe or something. I don't know, I didn't study architecture, I didn't yeah, maybe I should have studied architecture, but anyway, this is like another quick look at Sverchok nodes and how you can create this kind of structure based on a plane, and all there's these numbers, and then kind of there's this Sverchok kind of magic, list repeater, list join. Is yeah, just give it a try. I'll give you this node setup for you to play with. Feel free to make changes and let me know if you have made something interesting. Thanks again for tuning in. I'll see you in the next video.